Hey everybody, in this video we're going to talk about graphing a hyperbola centered at the origin, or ax² plus by² equals c. So here we're given an equation, -x² plus 9y² equals 9. First let's go ahead and take a look at the steps I want you to follow in order to graph a hyperbola. A little more simple than finding each and every single part of the hyperbola. Okay. So here are some good steps to follow when we're graphing a hyperbola. First step is to identify the center and vertices. So let's take a look at this equation and go ahead and identify those. The center for this one happens to be at 0, 0. So here's our center. Our vertices are going to happen, well, let's take a look at this. 16 is a² because that's our positive, that's the denominator of our positive fraction. So what does that mean? That means we're going to open sideways and we're going to our vertices to find our foci, or from our center to find our vertices, we're going to add in the x direction. We're going to take 0 plus or minus a, which is 4, and 0. So our two vertices are at 4, 0, and then -4, 0. So we have our two vertices here, like so. Now it says to draw a reference rectangle centered at the center of the hyperbola with dimensions 2a and 2b. Okay, so let's first find a. A equals 4. Now let's find b. B equals 3. So what does it mean to go out 2a from the center? Well, that's where our vertices are, right? I can go out 1a from the center to my vertice, and that's a, and another a from my center to my other vertice, and that's a as well. And then I'm going to go out b in the other direction, 1, 2, 3, 1, 2, 3, like so, and I'm going to draw this little box here. I'm going to talk about what that box is in a minute. I want you to think back on the equation of the asymptotes. For a hyperbola that opens sideways, we end up getting y minus k equals plus or minus what? B over a times x minus h. Now the b is a slope. This is the equation of a line. So b is the rise of the slope, and a is the run of the slope. Look at this. From the center, if I rise b, which is 3, and run 4, I get the next point of my asymptote. So step 3 says to draw the asymptotes to the opposite corners of the rectangle. And that's because that rectangle gives us like the slope of these lines here. Okay, so there's my asymptotes, like that. And then step 4 says to sketch each branch of the hyperbola starting at the vertice, and then it's going to start approaching that asymptote as it goes out like this. So again, that's why hyperbolas are different than parabolas, because we aren't following this quadratic end behavior. We're starting to follow those lines. So that is how you graph that hyperbola. Go ahead and go back to this problem where now we aren't given something in standard form or in general form, so we need to put it into general form. Which the squares are already completed here, so I don't need to do anything like there. It is centered at the origin. I need to divide by 9 on both sides, so I end up getting an equals 1. And I end up getting y² divided by 1 minus x² divided by 9. I rearranged it a little bit because I want the minus sign there. So we can see here's an example of where a squared looks smaller than b squared, right? A squared equals 1 and b squared equals 9, but it is a underneath the y squared because the negative is attached to this fraction that has the x squared term. So here's my equation here, which means a equals 1 and b equals 3. I'm centered at 0, 0 again. Okay. With the a squared being over the y squared, that means we're going to open up and down. So my vertices, I'm going to add and subtract 1 from my y coordinate. So my vertices end up being at 0, 1 and 0, negative 1. And then I go ahead and I draw my box. I've already gone out a from my vertex. So now I need to go out b in the other direction. So I go 1, 2, 3 on to the right and 1, 2, 3 to the left. And I kind of build this box here. Now we can see this box is going to be nice and skinny. And then I go ahead and I draw in my asymptotes like this. And then for my vertices, now remember where those are, because these points right here aren't vertices, so make sure you keep that straight, okay? That just helped me draw my box. And then for my vertices, I go ahead and I start approaching these asymptotes here, like this. Okay, so that is how we can graph a hyperbola that is centered at the origin.